Let's learn how to verify trig identities. Today we're going to talk about how do you verify. I'll give you some tips on verifying. We are going to look at factoring with trig functions, and then we'll work through some examples. So let's get ready. You need your notes, pencil, and your trig identity sheet. Make sure you take notes on the tips and watch me do a few and then try some on your own. So when verifying, you should transform one side of the equation until it is the exact same as the other. Do not cross the equal sign. So this is kind of goes against everything you've learned in algebra. If you do something to one side, you have to do it to the other side. We are not doing that. We are only working on one side. We're manipulating it. We're substituting things in to get it to look exactly like the other side. One tip is it's often helpful to put things in terms of sine and cosine, and that may help you simplify more. Another tip is to start on the more complex side. It gives you more to work with, and you have to show every step. I know some of you are not going to like that, but you have to show every step along the way. I can't just guess what you're doing from one step to the next. So some of the algebra that you might need to do when you're verifying is you may have to factor. You may have to multiply by the conjugate, and if it's a fraction, you can multiply by the conjugate of the numerator or denominator. You might have to write it in different terms, substitute in an ID. Get a common denominator. Separate one fraction into two fractions. We'll look at an example of that because this one is not that common of a thing that kids would remember to do. So let's start with this one. Here we have our first trig identity. You can see we have fractions on the left, we have a cosecant on the right, we have the full equation. It's kind of like in geometry when you were given a given statement and you were given the proof statement, so you knew the beginning, you knew the end, and you had to fill in all of the middle. We're not writing a two-column proof where you have to give every reason and every statement, but you do have to show every step. So one of the earlier tips said to start on the more complicated side. So I'm going to start on the left side because there's not really a lot I can do with cosecant. I see that I have two fractions, and most of the time when you have fractions, getting a common denominator would be a good thing. So the first thing I'm going to do is I'm going to get a common denominator. So that means it would be the sine theta and 1 plus cosine theta. Those are going to be the two pieces that I need in my denominator. So the first fraction needs to get multiplied by sine on the numerator and the denominator. I'm going to add some parentheses there. And then the second one needs to get multiplied by 1 plus cosine. And then I have the same denominator. And if you want, you can just write equals down the right-hand side here, but we're not touching that right-hand side. So now I'm going to look at what I have. I'm going to simplify up my numerator. So sine times sine is sine squared. Make sure you're putting the 2 there before the theta. I'm going to distribute the cosine on the other fraction. So I'm going to get cosine theta plus cosine squared theta and put it all over the same denominator. I am not going to multiply it out because maybe something will simplify along the way later and I'll be able to cross something off. So take a look at what you have now, and I see I have sine squared plus cosine squared. That is an identity. Together that equals 1. So I'm going to substitute in 1. So 1 plus cosine theta all over my denominator, 1 plus cosine theta. And hopefully you can see why I didn't multiply my denominator, because now I have the same factor in the numerator and the denominator, so I can cancel that. Remember, the sine has to stay in the denominator. You have a 1 in your numerator, so it's 1 over sine theta. And we're getting closer. Remember, we're trying to get to cosecant, so I can use the reciprocal, and cosecant theta equals cosecant, theta. And you're finished when it is exactly the same. On the right-hand side, I could have equal signs here and be writing cosecant as well. And there it is, so you can see it all neater. Let's just take a minute and look at factoring with trig expressions. We've done U substitution before. In this PowerPoint, I just used the letter A. So if I have sine squared x minus 1, that is a difference of 2 squares. Over to the right-hand side, I've simplified it. I've took out the word sine, and I remember that a difference of 2 squares simplifies to a minus 1 and a plus 1, a being my sine. So that means I can factor this to sine x minus 1 and sine x plus 1. So we may have to factor along the way. Here I have a trinomial. It's a quadratic trinomial. So if I substitute in with a's, I can figure out my numbers first. A is 4, C is -3. So I'm trying to think of what multiplies to -12 and adds to 1. That's a +4 and a 3. So I'm going to substitute those in for my middle term so that I can factor by grouping. Oh, that's supposed to be a -3. And then I can group the first two and factor out a 4a to leave behind a plus 1. I'm going to factor out a -3 to leave behind an a plus 1. My parentheses are the same, so I'm going to factor those out. And the other parenthesis is 4a minus 3. So now wherever I have the a, I'm just going to put in tangent. So tangent of theta plus 1 and 4 tangent of theta minus 3. You don't need to do this whole right-hand side. Maybe you can do factoring the quadratic with tangent. Let's try this one. I do have a quadratic trinomial, but now it's got secant and tangent. So I do remember secant squared is one of my Pythagorean identities. So I'm going to substitute that in. It's the same as 1 plus tangent of squared of alpha. So I substitute, that's the whole substitution, and then I'm going to continue my expression. Now I have at least the same trig function. It is quadratic. I'm going to put it in standard form. So tangent squared alpha minus tan alpha minus 2. I'm going to factor that. I am going to go straight to factoring because a isn't 1. So it just becomes tan alpha minus 2 and tan alpha plus 1. That's what it factors to. So these were just expressions we may need to factor along the way. All right, let's get back to verifying our identity. So here I have both sides. I'm going to start on the left side. And I have a fraction, and this is the first time I'm showing you splitting the denominator. So this is kind of like if I had a minus b all over a, and I separate the denominator. So I put an a under the a and an a under the b. And it's just like working backwards from getting a common denominator. Now I can see a over a would be 1 minus b over a, and I can keep moving from there. So separating the denominator is when you have only one thing in the denominator and you put it under the pieces of your numerator. So I'm going to do that. I'm going to separate the denominator, and that becomes secant squared over secant squared minus 1 over secant squared. From there, secant squared over secant squared is 1, and then 1 over secant squared is cosine. And then this is an identity, and it is cosine squared x plus sine squared x equals 1. It's that one rearranged, so if I subtract the cosine squared over, then this is going to equal sine squared x, and I have the same exact on the right-hand side. Let's look at this one. So there's a lot on both sides. I am going to work on the left side. And in this one, I have tangent and cotangent. And I'm going to do that suggestion of trying to rewrite things in terms of sine and cosine. So tangent is sine over cosine. Cotangent is the reciprocal of that. It's cosine over sine. And now I have two fractions. I'm going to get a common denominator. So I'm going to multiply the first by sine, top and bottom, and the second one by cosine. And in my numerator, I get sine squared theta plus cosine squared theta all over my denominator, cosine sine. And here's our Pythagorean identity. Again, you've got to get used to seeing that because that represents 1. So now I have 1 over cosine sine. I would have all my equal signs here. And then I'm back to reciprocals. So 1 over cosine is secant, and 1 over sine is cosecant. And I have the same thing on the other side. So I have verified the proof. And let's try one more. And this time I'm going to work on the right side. and I have cosine over 1 minus sine theta, I'm going to do the conjugate. So an example of that. So I'm going to just keep my equal sign here in the middle so I have enough room. So I have cosine theta over 1 minus sine theta. I'm going to do the conjugate of the denominator. Top and bottom, I'm allowed to do that because it is just 1. This time I'm just going to leave the numerator in factored form again in case something will simplify. And let's take a look at what happens to the denominator. So it is a basically backwards difference of two squares, so it becomes 1 minus sine squared, and 1 minus sine squared is cosine squared. So this becomes cosine 1 plus sine squared over cosine squared. And I have a cosine in my numerator and denominator, so I'm going to cancel this one and the squared, but I still have 1 in the denominator. So cosine over cosine is 1. I've simplified that. And now I have 1 plus sine theta all over cosine theta. It kind of feels like we're going in circles because we just have a fraction again, but now I only have one thing in my denominator, so I'm going to split my denominator again. So 1 over cosine plus sine over cosine, and that's going to equal the reciprocal, so it's secant theta plus the quotient tangent theta, and that equals the same as the left side. And we did it. So just some reminders, decide which side you're working on. It's usually better to start on the more complicated side. You can only work on one side. Do not cross the equal sign. Always work down the page. I forgot to say that, but it's going to be a lot easier to read as you work down the page. The sides have to match exactly when you're finished and show every step along the way. Good job.